Now, the last concept that we're going to talk about with statistics is that one outcome that's kind of by itself. It's going to be talking about confidence intervals, confidence level. So we're going to talk about a few different definitions, and then we're going to get into some quick examples. First definition is margin of error. Now, margin of error is the possible difference between the estimates of a value we're trying to determine, as determined from a random sample, and the true value for the population. Now, margin of error is typically measured in a plus minus. So it could be up to a certain value or minus a certain value, and we'll see what that means in the next question. This is a symbol for just saying, okay, it could be adding it or it could be subtracting it. The next thing is the confidence interval. So that is an interval in which the true value you're trying to determine is estimated to lie. So saying, okay, it should be somewhere in this certain interval, also known as this certain range of values. It's usually stated with some kind of degree of probability. And that actually talks about the confidence level, which is the likelihood that the result for a true population lies within the range of the confidence interval. With confidence level, the margin of error decreases when the sample size is larger. So meaning, if you increase the amount of data you have, the chances of you being out of a confidence interval, that's going to decrease your margin of error. And we'll see exactly what that means in some of our examples. Example one is a survey says that 76% of people have a social networking account. Results are accurate plus or minus 4 percent points, 19 times out of 20. Population of the survey is 92,500 people. Determine the confidence interval and confidence level. How many people have a social networking account? So if the survey says that 76% of people have a social networking, well, then we should be about 76%. But it says that it's accurate plus or minus 4 percent points. I think I need a word within here. Which means from that 76%, it could be plus or minus 4%. This entire thing right here is a confidence interval. Another way, obviously, of notating this is because if it's 76% plus or minus 4%, well, if you subtract 4%, it'd be 72. If you add 4%, it'd be 80. So the confidence interval in its condensed form is written like this. This would be its basically literal translation. The plus or minus 4% is the margin of error. Which means we could be anywhere within plus or minus 4% of this 76. We could be anywhere in between 72 and 80%. So it could be 73, could be 79.8. It could be 76.001. So this allows us to say that, yeah, we're close. How close? Well, we're somewhere in this range. This is where we're confident that our ranges, that our value is going to be in between. Now the confidence level typically has 3 different values. Either it's 90, 95, or 99. And that's actually what this is. If it's accurate 19 times out of 20, it's 95%. So what that means is after this survey, you're 95% sure 72% to 80% of people have social networking. So the next bit of the question is, how many people have a social networking account? Well, we're somewhere between 72% and 80%. So if we find out what 72% is of this and 80% of that is, we know how many people have a social networking account. So 72% is 66,600 people, and the 80% is 74,000. So there's somewhere between 600 or 66,600 people and 74,000 people have some kind of social networking. The next example, a baseball company stops production when a random sample of baseballs is outside of the margin of error. The standard size for baseball has a mean of 145 grams. Confidence interval is 144.7 to 145.3. What is the margin of error? Well, the quick bit of understanding is if our average should be around 145, the minimum is 144.7, and the maximum is 145.3, the margin of error is the difference between the estimate of the value you're trying compared to the true value. So we want our average to be 145. At the same time, the variance could be between 144.7 and 145.3. What is that difference? Well, it could be 0.3 grams above it, $144.7, subtracting 145. Could be 0.3 of a gram below it, which means the margin of error is just plus or minus 0.3 grams. If we wrote it as an interval, we would write it as 145.0 grams plus or minus 0.3 grams. And we'll have one more example. Right? Yeah, there's only one. A voting poll was conducted in Grenfell, Sask. The results indicated that 50% of people would vote for Elmo and 47% would vote for Chase in the upcoming election. The results were stated to be accurate within plus or minus 3.8%, 19 times out of 20. Who will win the election? We're going to use a number line. So it says that for Elmo, he should win 53% of the votes. So for Elmo, he should win 53% of the votes. But it's accurate to within 3.8%. So plus or minus 3.8. Which means if we added that 3.8, it'd be 56.8. If we subtracted it, we get 49.2%. So I'm just going to move Elmo up here. It also says that 47% vote for Chase. Again, accurate within plus or minus 3.8%. So if we subtract it to 3.8, 47, subtract 3.8, is 43.2. If we added 3.8, it's 50.8. So what all this means is the votes for Elmo could be all the way up to 58 for 56.8, or it could be all the way down to 49.2. The votes for Chase could be all the way up to 50.8, or all the way down to 43.2. So if it's accurate 19 times out of 20, who will win the election? Likely, Elmo should. But because you're only accurate 95% of the time, so Elmo should win. But Chase still has a chance. When you start following elections, for example, in any kind of election year, it absolutely will, you'll see a lot of these kinds of statistics, accurate within 1.7%, or in this case, 3.8%. It helps you deal with some kind of probability of whether things are going to happen. Now, as I had made a mention, with confidence level, the margin of error decreases when the sample size is larger, which means if this is like this, maybe only 1,000 people were voted or were surveyed. In Grenfell, that's a huge amount. That's almost everyone. So you should be very accurate. So 3.8%. But if we only interviewed 20 people, so only these 20 people, you would not be very accurate. The error would probably be, so with 1,000 people, it's accurate within plus or minus 3.8%. Whereas in this case, our margin of error would actually go backwards. If you only survey 20 people, it could be plus or minus 20%, because you would not be very accurate. Meaning Chase could win up to 67%, but Elmo could be all the way down at 33%, which offers a lot of margin of error. Alrighty, you can have some fun.